Our next chapter is on approximation or rounding. Last year, we rounded up to the thousands. So, for example, what that means is that if you had a number, last year, for example, 3,512, and you were rounding to the nearest hundred, you would look at your hundreds digit. In this case, my hundreds digit is this 5, okay, because it's in the hundreds. And to round this number to the nearest hundred, I would actually look at my number to the right. And I sometimes draw little eyes, so I remember that this is where I got to look. And the rule tells me that if the number to the right of the digit I am rounding is 5 or more, so 5 or greater than 5, then my number that I'm rounding, which in this case is this 5 because I'm rounding to the nearest hundred, is going to go up 1. Okay? The rule says that if the number to the right is less than 5, then the number I'm rounding, which in this case again is a 5 because I'm doing it to the nearest hundred, my number is going to stay the same. So looking at my number of 3,512, my hundreds digit is a 5. I look to the right, and the number to the right is a 1. So it's less than 5. So this number, rounded to the nearest hundred, is going to be 3,500. Because this is, the 1 is less than 5, so that 5 is going to stay the same. You wouldn't change a 3 because the 3 is before the 5, and it's in the thousands, which was not affected by rounding the 5 to the nearest hundred. Every number after the number that you rounded becomes zeros. So that's why the 1 and the 2 are now zeros. Okay? Now you're probably wondering, why do we need to round? Well, round is important when you are going to estimate. And we will be using rounding to estimate answers to addition problems, subtraction problems, multiplication problems, division problems. It helps you to know whether your answer is reasonable or not. So for example, let me give you a quick example. If I have 368 plus 213, I can round and get an estimate of my answer so that when I do actually add it, I know whether or not my answer is reasonable. So for example, if I round this to the nearest hundred, here's my 3, I'm looking at the 6, so that's 5 or more, so this rounded is going to be 400, plus, here's my 2, my hundreds digit, I have a 1, so this 2 is going to stay the same, so this is 200, so my estimate is 600. So then when I actually add these numbers, 368 plus 213, this is 11, 8, and 5. My number, my answer should be close to my estimate. And that tells me whether or not this answer is reasonable. So for example, if I would have added wrong and I would have had an 8 here, but my estimate is 600, then I know I got to go back and check my work because my answer is very far away from my estimate. So that's how we're going to be using rounding. So let's look at another number and look at how we would round that other number. So now if I were to round, let's say I'm going to round 6,782. And I'm rounding this to the nearest 1,000 now. So I'm not going to look at the 7. I'm going to be looking at the 6 because that's the number I'm rounding. So it's to the nearest 1,000. That's the place value. So I'm going to look to the number to the right, which is a 7. The rule says that if it's 5 or more, this number is going to go up 1. So this number rounded to the nearest 1,000 is going to be 7,000. You change a digit that you're rounding, and everything after it becomes 0. So the 7, 8, and 2 are now zeros. Let's round another number. We'll do 9,871, and we're going to round that to the nearest 1,000 again. Now something interesting happens here because I have an 8 next to it. And because I have an 8, that 9 is going to go up 1, which means that 9 is going to become, what's one more? It would be 10. So 9,871 rounded to the nearest 1,000 becomes 10,000. Because this 9 goes up by 1, so it becomes 10. And then everything after it becomes zeros. So this is just a preview of our next chapter. And hopefully when we start it, you have an idea of where we're going to go. And we will be rounding numbers all the way to the 100 millions. So get ready for an approximation adventure.